All right, hello and welcome to your lab. Let's go ahead and get started. So you're on this page, you're watching me on this video that I'm about to replace, which is weird to think about. So let us go ahead and get started. Open up the Lab 00 right up. I'll make it all large for us. And let's get started. So there's a lot of little things that have to be done in order to complete this lab and then turn it in, but after doing it once, I promise you'll get used to it. Okay, so this is due in, if you're watching this on the Friday, in a week. It's going to be due on the 22nd at 5, and let us begin. So I have made a set of slides to go over these things, so let's head right on into it. We're going to first take a look at the write-up. I do want to point out that this is probably the easiest lab. This is definitely the easiest lab by far, in fact. So don't waste any of your drop scores on this one. So the first thing that you need to do is to get into your virtual machine. This one's yours. Fire up the terminal, and the first command that I want you to run is refresh -starter -code. Okay, so depending on whether or not I've changed things, you will see something different here, but you'll always do that before every lab. Okay, then you are going to find a spot, a nice spot for your code. Okay, so where do you want to work on your lab? If you made a shared folder, now is the time to go into that shared folder in your terminal. Okay, because you're going to do a terminal command that will download the starter code, and you'll start working in whatever folder is your current working directory. Okay, so the first thing that you need to do is find that place. So assuming you made a nice spot, go there. I'm going to make just a silly little labs folder for myself on this desktop. Really, you should be using your shared folders. And I can CD on into that by dragging it up or doing the fancy process. So it's empty right now, and what we're going to do is we're going to run this command right here. That dot at the end is very important. It stands for the current working directory. So it's saying copy this folder that I'm about to type, this one right here, into the current directory. That's what it's saying. Okay? So in theory, I am able to copy and paste it. Go back. Yeah. And there it goes, and now it's made that, that folder, and you can look at it in any way that you want. Double click, and here is all the stuff. Okay, so lots of files for you. Okay, so this is what you should see. And yes, everything worked out perfectly. You should definitely remember to change your server password if you haven't. But now you're ready to start working. And in order to work, you're going to have to edit and compile code on this virtual machine. So let's start with editing. I've installed Visual Studio Code, Vim, and Emacs on the virtual machine, and you are welcome to install whatever you want if you know how. I'd be happy to teach you as well. So if you haven't heard of any of these before and you've used something different in your previous classes, just use Visual Studio Code. It's the easiest. Okay, and if you like Vim but you don't know how to make it do auto-completion, it's a lot easier to just use Visual Studio Code and install the Vim plugin. Okay, I'm not going to force you to use the terminal in this class for your editing. Okay, so this is stuff from CSCI 40, sorry. So you can just drag the folder on in here that you want to do your work in. It's quite helpful. It'll add it. There it is. Here's all the files. Yeah, and if you'd like help configuring your Vim or something, please come to office hours if you're not in the mood for Visual Studio Code. So you can type away, start editing and things. So you'll edit this hello.cpp file first of all. And once you're ready to compile and run your program, I'm going to show you what to do now. All right, so the very first thing that you're going to do is really this lab is to warm you up to programming again. So you're going to do some very simple things. So the first thing is the simplest. You're going to write a hello world program that just runs and outputs hello, comma, world, exclamation point, I am ready for CSCI 26, exclamation point, followed by a new line. Okay, so let's get there. Boop. Let me do some of this for you. include stream using namespace standard int main, and always a return 0. So I'm going to purposefully do this wrong. Hello world, and maybe 2 new lines, just for fun. Okay, so it's wrong, but it's a correct program. So how do you compile and run this? Okay, this might also be new for you if you didn't take 40 and 41 here. So to compile and run a program, open up the terminal and get to where you saved the file. You're going to change directories to there, and we've already done that. Okay, so if you somehow did not learn the terminal in your previous classes, read that Learning the Shell guide in the optional reading page on Canvas, and like the second module that will teach you how to do things, and also come to office hours and I can give you a quick tutorial if you'd like. But we're going to use this thing called G++, that is our compiler. Okay, we say G++, we say that we want to use the C++ 2017 version of the language, and then we give all the things that we want to compile. If it's just one file, we give the file by itself, and then -o, and then finally the name of the file that we want to compile into. So to compile hello.cpp, for example, we can say G++ standard equals C++ 17 hello.cpp-o, and I like to call it the same name, so hello. And now it's made this new file for me that is executable, nice and green. You can say /hello, enter to run it. Okay, and so it runs my program just like that. So I'll remove this file, because that's the hard way to compile things, but I want to make sure that you know how. Okay, really, I have made a makefile for you. Okay, so just remember, if you're ever going to compile something, this is a C++ 17 house. You always use this one because the older versions of the language work differently or don't have stuff. Okay, if you forget this, some of the fancy headers that we include in later labs will not work, okay, because they don't exist in that version of the language. Okay, so just keep that in mind. But yeah, really, to compile things, you can use the makefile that I've given you. You can just say make hello, and it will compile it for you because I made this fancy makefile. Okay, so it'll say, you can say make hello, and it will run the compiler and create the hello executable. Okay, so alternatively, make hello, and it essentially does the same thing. It goes through a .o file, and bam, we have our running program. Okay, so you're going to do that, get it working perfectly, of course. Printing all the correct stuff this time, but don't worry, we'll get there. The next thing that you're going to do is determine primality. So you're going to implement a function that gives back true or false in primes.cpp, depending on whether a given input number is prime. So you can pretend or assume that your input value x is always greater than or equal to 2, and it's your job to discover whether or not that x that you're given is prime. So you'll implement this function right here in primes.cpp. So look forward to that. Yeah, I don't have a lot to tell you about that. There's some pseudocode in section 9.4 and of your book. We can go to that quickly. And so just to get you started, let me implement this for you in Racket so that you see even more Racket. Okay, so here is like the simplest way to test if a integer greater than 1 is prime. Okay, you'll just try to divide it by every number between 2 and n-1. So, I don't know the best way to do this because oh, actually, we can use Racket's included programming environment. There's this program called Dr. Racket that will be very helpful for me now because I'm not on my normal virtual machine. You can write Racket code in here. So let me show you all this stuff once it starts loading. Okay, Dr. Racket is open. I have made it huge, and what you can do is write your program up here, and then you have a REPL down here. So you can say like printf, hi mom, run the program up here, and hey, it works. Okay, so we'll write our function up here. I'll give an example of what you're about to implement for this isPrime function. So in Racket, you'll say something like define prime question mark. That's how they like to name their predicates, and because it's a function, we put some parentheses here just like that, and then we give the body of the function. And so we just keep on implementing all this stuff. So for x going from 2 to n minus 1, well, this is how you can do a for loop. And say for, well, we're going to call it I. For I going between 2 and x minus 1. For some reason, it just goes up to x minus 1 when you put x there. That happens. And then we have more stuff that goes here, and then we close our for loop. How I'd like to implement this, and you might like to do it the same, is to start out with a guess, with a local variable saying define is it prime? Well, we think it's true that it's prime, and eventually at the end of this we'll return back our is prime variable. But at the very beginning we're not sure. So we think it's true, but we might be surprised in here when one of these variables evenly divides into x. Okay, so the number is not prime if ever I divides cleanly into it. Okay, so think modulo for this, okay? That's how you can get remainders and notice if something divided in cleanly with integers. So something like an if statement. So whenever, if it ever becomes the case that x mod I is 0, and in bracket you say equals modulo xi 0, so whenever x mod I is equal to 0, if that's true, then in the body of this when statement, we will set our is prime to false, because we found a counterexample for that. So that was no fun. And there, that ends the when, and the for as well. And then at the very end of that, we're going to return back is prime. So it was either true or we changed it to false when we found something that actually divided into it. Okay, so let's see if that actually compiles. Yes, it does. Let's say prime, question mark, something like 5. That is true. What about, can I press, no, prime question mark 6. That's not true because we're going to start I at 2, and immediately it's going to notice that 2, or 6 mod 2, is 0, because it goes in cleanly 3 times. And also when I is 3, he'll do this all over again. So there are many reasons for it to not be prime. And then always check your corner cases. It's 2 prime. Yes, it is, because of the way this loop works. Okay, it doesn't hit 2. So that is one way that you can do this. You are welcome for that implementation. So yeah, implement is prime. So that's primality. And the next thing you're going to do is really fun. You're going to calculate pi by throwing darts. So I have 2 nice diagrams for you here. So feel free to read this, but let me try and explain it to you. So here is a 2x2 square that houses a 1x1 circle, because we can pretend that this is like the origin 0, 0, and this is a radius 1 circle, and so obviously the diameter is 2. We can put a box around it, a perfect square that just perfectly touches all the sides, and that's 2x2, of course. And then what we can do is randomly throw darts onto this square, okay? Hopefully at the dartboard. If we randomly throw it, and they always land somewhere in this square, could be in the circle, could be outside, with enough darts we're going to approximate pi. And the reason has to do with the ratio of the area of the circle to the area of the square. Okay, so let's pretend we're randomly throwing darts and they're hitting a bunch of random places. The odds of it hitting this circle as opposed to outside of it have to do with the area of that circle. Okay, so the idea is the number of darts that land inside this circle divided by the number of darts inside the square that encloses the circle is the same as it's the area of the circle divided by the area of the square. So what's the area of this unit circle? Well, it's pi r squared, pi 1 squared. That's just pi. And then the area of this square, this outer enclosing square, it's 2 by 2, right? So 2 times 2, that's 4. And so we get pi over 4 is the ratio of the darts that land inside the circle to the darts that land anywhere. Okay, total darts thrown, that is. So, maybe I should say this, total darts thrown. Just so that we don't get confused. Let's put pi over 4 on it, same line. There we go. So, that's wonderful. That's a really cool way to find and calculate pi. We're also going to do one optimization because random numbers come easier in the first quadrant. We can just make a bunch of positive, non-negative random numbers. So we're only going to consider throwing darts in this rainbow square, this first quadrant, okay? Because these are like the axes, right? It turns out that the ratio still holds. You just count the number of things that land inside this part of the circle to the number of things that land anywhere, the number of darts that you threw, and it's still pi over 4. Okay, so you can use the same exact idea. We're just going to throw darts only up here. All right, this converges horribly, but it's really cool. Okay, so I hope you understand the game. You're just going to randomly throw darts and figure out how many of them are inside the circle. Then you're halfway there. Then you have an approximation for pi over 4, and you just need to turn that into an approximation of pi. Okay? So, yeah, what I've done is made this for you. So here is pi.h. I've made a point class that keeps track of points in space. So like you can say point p 2, 3, and that gives you the coordinate 2, 2, 3. That one. Okay, something like that. But the way I want you to use it is to call this uniform random point method. Okay? That's what I want you to do. And it's a special new kind of method. It's a static method. We'll talk about that in a second. So you use these points to implement this approximate pi function in pi.cpp. Okay? So your only job is to implement this function. So you know how many darts you're throwing, and you just need to throw that many of them. Throwing a dart is equivalent to calling this uniform random point function to get a random point back. And then you just count how many were inside the circle. Okay? Then you're halfway there. All right, hopefully the process makes sense to you. And yeah, the last piece of the puzzle is, what in the world does a static function mean? So let's talk about that. So a static method, is it's a method that belongs to the class itself rather than to an object. Technically, you can use dot to call it, I think. Let me say shouldn't instead. So dot shouldn't be used to call it. Instead, you'll say, because it belongs to the class, not an object, has no this variable defined, you say class name : then the static method, and that's how you call it, okay? So you don't need any objects to call it, which is fun to think about. So let me give you an example of that, I guess in hello.cpp, because why not? Let me make a class for you, class C, and public, I don't know, static int get 42 or something. Let's make this larger for you. Return 42. So look what I can do. I don't have to do this. This works, but it's silly. C dot get 42. You can see out that if I really wanted to. Okay. Make hello. There it goes. Hello world 42. But that's unnecessary. That's kind of silly. Instead, what you should be doing is class name C : get 42. It belongs to the class itself. We don't care about C. Little c, that is. Recompile does the same thing. And then finally, you thought that you always needed an object to call methods on, but when it's static, you don't even need an object to exist because it's part of the class itself. So this should be weird, right? It's still going to work. See that? How odd. That's what it means to be a static method. It belongs to the class, and you can just call it. So if you want to call uniform random point, you say point : uniform random point, parenthesis, parenthesis. And this will get you a random point with its x and y values between 0 and 1, and that's exactly what you want to get a random point in the first quadrant. Okay? So use this method to throw a random dart, and then figure out if it's inside the circle or outside. And then, yeah, just count that ratio and divide and turn pi over 4 into pi. That shouldn't be too bad, I hope. So that is your third and final objective for this lab. Okay, so once you got it all and you're good to go, let's talk about turning in your lab. So I really want you to get in the habit of always checking your grade, okay? So don't submit your code to the auto grader and just assume, yeah, it's perfect. You might be very surprised. So always check your grade. Run my tests that I've made for you already. I've made these test primes and test pi files. So do that. Here's my, you can use the make file to compile them again. So here's my test pi tests for you. Make sure that those pass. It calls this assert true method that is defined in testing.cpp. Just make sure that the boolean that was passed was true. Yeah, that's test pi and test primes. So yeah, make sure that those all pass for you. Fix them if they don't, and then you're ready to turn in your assignment. So what you do is you make sure you're in your implementation directory in the terminal, and then you'll run this command. You'll say turn in, then the name of the lab, and then the @ sign, and then the name of the class, so it's like an email. So lab00 at CSCI26, then you turn in these files that you implemented. And you can turn it in early to get partial credit if you'd like. You can turn in just one file if you'd like to. That totally works. So yeah, once you're ready, or once you want partial credit, just run this command and prepare to log into the server. So you're going to use your server username, which is your last name underscore your student ID, and then your password. And that's going to turn in your lab, and hopefully it all works for you. It should say submitted successfully. If it doesn't, please yell at me. The one thing that is possible is you're not in the right folder, like these files that you're trying to submit don't exist, and you need to CD into the right spot. So assuming it turns in properly, then just wait a little bit, 15 minutes max. It really should just be 10. Then you'll run refresh grades to download your graded results from the class server. And then finally, you'll run view grades on the terminal to look at them. Okay, so let me go and force the autograder to run quickly, and then I'll be right back. Okay, I have asked the autograder to hurry up, so now you'll run refresh grades to go and get your grades from any directory, doesn't matter. Then again, you'll log in. Boop, boop, boop. There it goes. Hopefully you don't see any errors. It's just downloading your stuff. And then you'll run view-grades to look at what's going on here. And this is going to pop up in Firefox, and you'll be able to click on which grade you want to look at. Slowly but surely, it's going to make it pop open. So here it goes, and you'll see, well, I don't think you're going to be in CSCI 40 and CSCI 26 at the same time, so you'll click on the one you want. And then it shows you all the information, like what you scored and the total points possible. So here is your hello, and you can see that your output's on the left, the expected output's on the right. It kind of hints at as to, oh, there should only have been one line and a new line, but you gave me 3. What was wrong with you? But this part was correct. And then it tells you about like the test primes, things like that. Okay, you got 6.5 out of 12. Good job, because you said that things were always prime or something. Okay, so I kind of helped you out there with my fancy implementation. And then finally, the test pi stuff. It seems to fail. Oh man. So, yeah, because I didn't implement anything yet. So yeah, just get all this working, and get your full credit, and that is the easiest lab. So I wish you luck. Please yell at me if you have any questions at all, or if anything wasn't clear, but that is the process. We have the longest video because I wanted to walk you through every bit of it, but now you are professionals. Okay, so here's the rubric. Here's everything that you need to do to get it all working. And yeah, I will see you next week.